So the next presenter is Monique Leroux, also from the CSR. She is going to be talking about local network impact studies, hosting capacity, etc. work that CSR has done. Monique, if you could load up your presentation meanwhile. So Monique is a senior researcher and electrical engineer with the CSR Energy Center. She's over 16 years of experience in power systems engineering within Eskom and the private sector, with a specific focus on grid connection and operation of renewable energy. Her most recent research with the CSR is focused on the grid integration and stability of large-scale variable renewable energy in South Africa. She holds a BEng in electrical and electronic engineering and an MSc in electrical engineering. So thanks for joining in, Monique, and take it away.
Okay, thank you very much, Mark. Yes, Monique Leroux, as Mark has said. Now I'm from the CSR, Warrick's colleague at the CSR, and where he focuses on energy modeling, we focus on grid modeling, where I'm the lead, and specifically focusing on at the moment, a lot of focus on the grid integration of renewable energy, which I'll be talking about today, but more looking at the local network impact and studies around that, and also like tools that's been made available by CSR that municipalities can use to assist in the integration of renewable energy onto their network. Okay, then Mark, I just want to check in, because I see everyone's on the side. Can you guys see my full screen, full presentation?
Your presentation is great, thanks.
Okay, all right, now I just wanted to check. Okay, some overview quickly about my presentation. Firstly, I'll be looking at just some background and context for our study, then the main challenges of SSEG integration, then the CSR study that was conducted with some municipalities, where we did a gap analysis and our findings from that. Then the CSR SSEG grid integration studies and support tools. We'll be looking at some standards and documents around that, just quickly on touching on that, and then going into the two tools that were developed by the CSR. First one is a load assessment tool, and then a hosting capacity tool, which we'll just cover today. Okay, obviously you don't have to go into much detail with this. Everyone knows that the energy sector has been struggling, and the public utility has been struggling to deliver reliable and affordable electricity to customers, and this has caused residential, industrial and commercial customers to opt into installing embedded generation onto the system. At the moment, the small-scale embedded generation for the purpose of this study will say that it's installations less than 1 megawatt. And then these installations obviously has the potential to compromise the grid and the quality of supply of the network. And then distribution network planners and operators need to mitigate against these impacts and what that means for the network. Okay, the CSR, in collaboration with the DMRE, SALGA and GIZ, has engaged with municipalities to try and understand the impact of SSEG on their network. And then we started a collaboration, and we did a collaborative study to try and support municipalities with the assessment of these impacts on their network. The municipalities were evaluated for their readiness to facilitate the SSEG, and a gap analysis was done in that regard to try and determine which gaps the municipality have in receiving and processing these applications and getting the SSEG onto their networks. Some of the gaps that were identified revolved around documents and standards and guidelines that should be used when assessing these applications. And then municipal engagements were conducted in the form of training and capacity building. And then we also developed, as mentioned, the support tools that the municipalities can use to do grid impact assessment. Okay, just quickly touching on this, some of the areas that the municipalities said that where they have challenges in getting SSEG onto the network, political and distribution network capacity were two of the smaller challenges. And then the approval process seemed to also be quite a big challenge. And then the biggest challenge was sorry, I'm really battling to see my screen, was the the technical capacity of the network, which revolves around the technical skills and capacity of the municipal technical employees and workers to process it and to make sound decisions on getting the SSEG onto the network. Sorry. Okay, then the availability and the application of tools. Some municipalities lacked appropriate tools to perform detailed studies, such as power network simulation tools. And then we found that the municipalities either didn't have the tools at all, the commercial network simulation tools, or if they had it, they didn't have licenses that gave them the functionality that they needed to run the studies. And then we also found that for detailed studies, the municipality would likely outsource most of the work to external service providers, and they would do the detailed studies, which obviously is not ideal. Okay, then the CSR partnered with 3 pilot municipalities to assess the technical aspects of SSEG onto the network, to determine which support they required and to inform them on what they needed to do in the growing SSEG market. And then, as mentioned, a gap analysis was performed, and then from that 4 metrics were found, which are the business processes, the skills and capacity of the personnel, then the data availability, and then the availability of applicable tools to assess the SSEG. And then based on the gap analysis conducted by the CSR, some areas were identified where we could provide support, and these 2 were particularly, I'll just go to the next slide. They particularly focus on the skills capacity, building skills capacity and getting municipalities up to date with what they need to consider when integrating the SSEG onto the network. And then secondly, we also focus on the availability of tools and to develop appropriate tools which the municipalities could use. Okay, then these are just a summary of the 3 areas that we focused on. The first one was the NRS recommendations, looking at some standards that can be applied by the municipalities. Mark also in his introduction touched on the NRS 097 series. And then the second was 2 tools. The first one was a simplified load flow tool, which is Excel based. And then the last one was a hosting capacity tool, which is a Dig Silent Power Factory tool. Okay, then just on the codes and standards, I'll just quickly go through this because this is not the detail of the study, but firstly, the 2 documents that were put forward that the municipalities can focus on was the NRS 097 documentation that contains specifics for the electricity supply industry and was developed by the industry expert to assist supply authorities. And then the Mpe guideline was another guideline that was developed by a German consulting company for GIZ, and which was made available to municipalities to assist their engineers with the integration of SSEG. Okay, just quickly on the NRS 097 series, I won't go into much detail for this. The guideline is specifically focused on LV connections, and it is important for municipalities to remember that this is not the standard, so it's not mandatory, but it does give a good recommendation that can be applied by municipalities on what is the best practice of getting SSEG onto the network and what should be considered. Okay, then just some limitations on the NRS 097 is it applies to SSEG connections where there's possible feedback onto the utility grid. It doesn't cover UPS or battery installations, which are obviously becoming increasingly popular. And then NRS 097-2-3 only applies to generators with a capacity smaller than 350 kVA or where the penetration levels are less than 75% of the transformer rating or less than 15% of the maximum feeder loading. And it doesn't cater for parallel transformer configurations. Okay, then the other guideline that I just quickly want to go through is the Mpe guideline. As mentioned, it was developed by a German consulting firm, but it did make reference to the South African grid code and NRS and VDE documentation. It makes recommendations on LV and MV grids where the NRS only focuses on LV, and it covers integration, a set of integration considerations for generators smaller than 100 kilowatts, and then also makes recommendations for generators between 100 kilowatts and 5 megawatts. And then it points to conditions where detailed analysis might be required and what the municipalities would need to do in this instance. And then also importantly, as I've mentioned, it also gives guidance on MV connections where NRS 097 only focus on LV connections. Okay, just some recommendations on which guidelines to use under which in which situation. As mentioned, NRS 097 is for penetration levels below 75% of the transformer rating or 15% of the max feeder loading, and is only at MV level. And then the MPE guideline gives also only up to 75% of the transformer rating or 15% of the MV feeder rating, but also makes recommendations on how to assess applications that's above 350 or below 5 MVA, and also gives the considerations that need to be taken into account for MV level connections. Okay, then just going quickly into the load flow assessment tool that was developed by the CSIR. Okay, just for some background, a load flow or power flow is the process of calculating the steady state conditions of the network. It is essential to the investigation of power system planning and operation, and load flow can be used to gain insight into the next network performance over a range of conditions. So that a load flow analysis will give you some insight into the network performance. As this diagram shows, it will give you the real and reactive power flows through the network, the steady state busbar voltages, the thermal voltage violations that could be expected on the network for certain conditions or certain plant that's added to your network, and then the effect of different loadings on your system. It is a three-phase balanced load flow calculation for various configurations. Okay, so the simplified load flow tool that was developed by the CSIR is an Excel-based tool, and Excel was chosen because it's widely available, it's got a minimal learning curve, and it's likely to be software that can be used by most municipalities and most technical personnel. The tool conducts power flow calculations on a simple network, which we'll quickly go through just after this, with a maximum of 4 buses. And then the tool is useful for situations where you would like to learn more about the load flow on networks obviously with SSEG connected. And the municipal networks can also be aggregated, and those networks can be analyzed with this tool. Okay, the load flow tool, as I've mentioned, I won't go through this too much. It is developed in Excel. It should be easily accessible to municipalities and would be easy to be used by the municipalities without any extra licenses or extra software. There are unfortunately some limitations in that it only accepts a radial network with a maximum number of buses, which is a 4-bus system. And then the output that we get from the tool is you can see the steady state voltages of the network, the power flows through the branches of the network, and then you can see if the voltage limits or thermal limits are violated when SSEG is connected. Okay, this is just the user interface of the tool in Excel. This is your first page that you would get when you open up the tool. And then this is just a sample of the 3-bus system. So for each 3-bus system, you would have 2 transmission lines. You can have a maximum of 2 parallel transmission lines and then 2 transformers. The tool allows for up to 4 buses, and then for 4 buses you can have 6 branches, but you must have at least 2 buses. And then other limitations of the tool are that you can have at most 2 transformers, or you can have at most 4 transmission lines in your system. And then also a transmission line can only be in parallel with another transmission line as is shown on the tool here, or the transformers need to be in parallel with each other if you've got two parallel transformers. And then you would have your external grid connected to that, and you can enter your parameters for your external grid, which would be obviously an aggregation of your municipal network where you would like to do your study. And your buses will be numbered here, and you can then we'll go into the input data that would need to be given, and then we'll just show the output that can be expected from the tool. Okay, you'll get a user pop-up window where you can enter your system data, where you can run your analysis, and where you can add additional SSEG. I forgot to mention that when you've added your input into the system, your lines and your transformers, and your system is balanced, you can add as much, or you can add SSEG and loads to any bus, and you can add as much as you want and then run your simulation. Yeah, this is just a look at your input data that you can input into your system. This is you can select your number of buses, your number of lines, and your number of transformers and your branches, and you also give the user an opportunity to number their buses. And then this is where you would enter your load data, your parent power, etc. And then your transformer data, your generator data is added here. And then also your line data, and you can give a summary of your configuration of how you want to configure your buses in your system. And then this is just your output, and your results will be given from that tool into the Excel, into an Excel spreadsheet that with a format that looks like this, where you will be able to just see a summary of your network configuration, just to give the user a summary of what their lines and buses, the generation where that's connected. And then it will give an output on your voltage of each bus, your total generation, your total load, and then it will give some output as to whether there are thermal violations, where those thermal violations are, and why it's basically the exceedance. And then also it will give you the same output for your voltage. Sorry, I should have done this. Okay, your voltage limitation, obviously for MV networks, it will look at where it's above or below the 5% plus minus threshold, and for LV networks, it will look at where it's above or below the plus minus 10% threshold, and that values will be captured in here, and the user can get it from there. Okay. The load flow tool looks at your power flow through your branches to determine if there are thermal violations. Also, will calculate your voltages at each of the bus bars. The tool has been tested on a few sample municipalities where we aggregated the networks and ran some studies with SSEG connected. As mentioned, it would have to be aggregated to a 3 or 4 bus system. And then the biggest challenge probably would be to select the right network and to aggregate your network into a 3 or 4 bus system, and to make sure that those parameters are in place. And then for that study, we compared the output of the Excel tool to Dixilent to see what the results are compared to what we would expect in a commercial tool like Dixilent, and we found a very good match of over 96% confidence level. Okay, then lastly, the hosting capacity tool, it's another tool that was developed by the CSR, and we'll go into that now. Okay, the hosting capacity is the amount of distributed energy resource that can be added to the network without compromising the power quality and reliability under existing control conditions and without implementing any network strengthening measures. So for this tool and for the standard calculations that are done on distribution networks, where the plant is connected, the generator plant is connected quite close to the substation or close to the bus bar, the main violations that you're looking at is over voltage and under voltage, and then thermal limits on the lines and the transformers. And that's what this tool used to determine the hosting capacity, how much generation can be added to a network. Okay, so we used two different methods to determine the hosting capacity on a distribution network. The first one was a deterministic method, which calculates the hosting capacity of a network by considering generation that is only connected to one node, and then increasing that generation by a constant increment, and then seeing where violations on the network in terms of voltage and thermal limits are seen. And then this method obviously is quite fast to implement and quite easy, but it unfortunately does not resemble a situation in reality where you would see multiple generators connecting on the same network, as this only considers generation at one busbar or at one node. And then the other method, which we also developed a tool for, is to calculate the hosting capacity, where you assume that there are multiple generators connecting at different locations, and then increasing the size of those generators across a range with set increments, and then seeing where voltage and thermal violations happen. This more closely reflects what's happening in the real world, because on your network you would typically not only have one generator at one bus, but you would rather want to look at a situation where there are multiple generators being integrated onto your system, and try and understand how that's going to impact your system. But for this method, obviously you would have via computation, it would take a bit longer to calculate.
Monique, sorry to interrupt. Could I give you a couple of minutes to wrap up?
Yes. How much time do I have left?
Well, you have been going for 20 minutes. So
oh, really?
Time
really flies.
2 or 3 minutes, that would be great.
Okay, now I'm almost done. I'll just go through this quickly. Okay, so this just, that tool is just for implementation on Dixilent. Unfortunately, that can't be done on Excel. And then you would just look at a situation where you, for the deterministic one, you would have a single generator connecting to your network. For the stochastic one, you would place generators throughout your network at locations, and then the tools will run and increase the generation in set step sizes, and then the tool will calculate where you're going to see voltage or thermal overload. And then this is just your hosting capacity per node, comparing the deterministic and the stochastic between each other. As you can see that your deterministic results show that you will have a lot more hosting capacity, or much greater hosting capacity using that method, because it only considers one bus in your system, one at a time. And your stochastic method will look at all your generation in your system. From that, you can see that your hosting capacity will be a lot less if you consider other generators in your network as well. Let me just quickly go through this. It also just shows here that as you increase your load in your system, your hosting capacity will decrease. So if your load is at 30% of its normal loading, your hosting capacity obviously would be a lot less than when your load is at 100%, which also just highlights to users that they need to consider the worst case scenario, which is low load, because that would give you the true hosting capacity, compared to if you had full load. Your hosting capacity will be a lot more, but that's not reflective of what can be expected on the network. Okay, I don't need to cover this slide because it just basically shows some more results. And then I just quickly want to show that this is where all the documentation can be found. It's all hosted on the SSEG website. The NRS documentation is there, the Mpe Guideline, and then also a booklet that was put out by the CSR, which basically contains all the information and all the details of the guidelines and the tools and the whole study that was conducted by CSR. And then the CSR load flow tool and the hosting capacity tool can also be found on that website with instructions for the user. Okay, that's it from me. Thank you very much.
Thank you, Monique. It looks like a really useful set of tools to facilitate generator integration. Thank you. I see there's the odd question around how to get hold of the tools, Monique, in the chat. Possibly you could just respond to those, point people in the right direction.
I will do that. Thank you.
Thank you. So thanks for your input, and let's